Hey, fifth grade, how you doing? I hope so far if you've had any questions, I've had a few people email me, so that's fine. Keep thinking about that if you have a big question for me. If you're watching this is for Wednesday, April 29th. So I'm actually talking to you a week in advance. So we're talking about next Wednesday, because today is Earth Day, the 22nd. So I'm a week ahead. So we're on session 4 in Module 1 and Unit 6. And it's cube sequencing again. All right. So now I've taken what Bridges wants me to talk to you about as a teacher, and I put it into these Bridges student book pages. So this is all the things the TE, Teacher's Edition, wanted me to show you for this section in the book. So 208, cube sequence, and then you graph the pairs. So almost every time you do a cube sequencing, they want you to graph the results, okay? So it's like figure out, like for 209 and 210, it's called short and tall towers. And these are those cubes, and they're building, it's almost like building blocks, okay? Think back to kindergarten. But, you know, you kind of, it helps to look for a pattern. So find the pattern for both the short and tall towers, and then you're going to plot them on the graph in 2 colors. They want you to see the short tower. If you plot each coordinate for the short tower, they want you to see how it goes up or down, and same with the tall tower. On page 211, it's just more cube sequencing. And just a quick review, because I don't want somebody forgetting. Remember, when you're making the ordered pairs for these cube sequencings, usually they give you 5 boxes. So the X is just the arrangement that it is. So this is the first one in all these arrangements. So this is 1, 2 because there's 2 cubes in there, okay? So this is arrangement 2, so that automatically means the X is 2, and the number of cubes in the picture is Y. So always remember that. So we're looking for a pattern of the Y's. What's going on with the Y's? Because the arrangements just go up 1, 2, 3, 4, 5, and on. The number of cubes is changing every time, so keep that in mind, okay? Now, if you look at workbook 212 and 213, we have these things called tile pools. And what they've done is they've given you a picture of tiles, okay? And in your drawings in the book, the outside border is in like a grayish color, and the inside is white. So what I did for mine is these X's, those are where the water is. Those where the water goes. Okay, so they're called, the X's are the water tiles, and then these outside ones are called the border tiles because they border the water tiles. So what we're looking at is, when we're looking at all this, arrangement 1 has 1 water tile, and arrangement 1 has 8 border tiles. Arrangement 2 has 4 water tiles and 12 borders. Arrangement 3, right here, has 9 water tiles and 16 border. And if you keep going up like this, you will see the pattern for the water is from arrangement 1 to arrangement 2, it goes up 3. And then arrangement 2 to arrangement 3, it goes up 5. So, and then the next one is 7. So it's going 3, 5, 7, 9, 11, and it keeps going up by 2 okay? Odd numbers, okay? Now you'll see the border goes up 4 every time, all right? So I've been looking for patterns. One of the example in the teacher's edition, one of the examples that a student gave is arrangement 1, looking at water, it has 1 row of 1. Arrangement 2 has 2 rows of 2. Arrangement 3 has 3 rows of 3. It's just one more way of looking at it, okay? So in the middle of our board, what I did is I did the first 5. Notice the arrangements, 1, 2, 3, 4, 5. That's when you know that those are the arrangements, okay? Because that X is always whatever arrangement you're looking at. Now the Y's for the water pairs, it's if you're just looking at the water pairs, which if you scan up here, these X's. So this is 1, 1, okay? 2, 4, because there's 4 water tiles. 3, 9, okay, and so forth. So the next 4, 16, and 5, 25. So some of you, probably Toby, for instance, you've already figured out way down here that for the water tiles, if you do arrangement squared, you get the number of tiles they're going to use for the water, okay? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So the formula for the water pairs is A squared, arrangement squared, okay? Now, if we look at the border pairs, okay, same arrangements, we have 8 tiles used in the first arrangement, 12 used in the second, 16 used in the third, and so forth. It's going up by 4 every time, okay? So, if we look down here, they're going to start asking you questions like, well, if you know arrangement 1 through 5, what is arrangement 10 going to be for water? Well, remember our formula. If I stick in any arrangement squared, it's going to tell me how many tiles are used for water. So arrangement 10 is 10 squared, or 100 tiles, okay? Now I came up for the border, I came up with, if you do A times 4 plus 4, you can stick in any arrangement, multiply by 4, and then add 4. And if you go back here, I'm not going to go through it, but let's just do 3 times 4 is 12, plus 4 is 16. So that formula works for the border, okay? All right, now, enough about those cube sequences. When we get to 217 through 219, this is all part of what's called Anthony's problem. Okay, real quick, you can read on page 217, you can read all about Anthony's problem. But what it boils down to is company 1, he wants to earn $1,000 and he wants to earn it as quick as he can. So they give you 2 scenarios and you have to figure it out. So company 1 is starting with $1 and doubling. Every day they double the dollars they give to Anthony. Okay? Company 2 just said, we're going to give you $75 a day. Okay? So as we double company 1, see we went from 1 to 2, double 2 is 4, double 4 is 8, and so on. Okay? But in the right column, when you look at this in the right column, you're keeping track of total money. So we start with $1, but then we add 2, day 2, so that's a total of $3 altogether. And then day 3, we add $4, so we add 3 plus 4, now we're up to $7. And you keep doing that till you reach, you pretty much have to go over 1,000. You're not going to get to 995 or whatever. You have to go over. It's not going to be exactly 1,000. So just you go past. What's the quickest way Anthony can if you use the double philosophy, double money every day. How quick can he get there? Company 2 is, it's just 75 bucks a day, 75. So you accumulate here as you go up. It's every day is another 75. So here on day 6, for instance, okay, Anthony in company 1 has got $63. Day 6, company 2 has given Anthony $450. Okay, so what's going to happen? Well, that's what you have to figure out. You have to keep that going straight down. You see there's a big chart for you to fill in. Now, when you're done with that, on 219 it says graph the results. And you'll see when you're done which company will give Anthony the quickest $1,000. When you're done, it'll be obvious, okay? On page 220 is just number patterns. I'm not even gonna go over those. That page looked really easy, okay? Now, this last section, what I wanted to go over real quick is on page 215, number 4, it talks about total tiles for like a certain arrangement for the border. Well, remember the formula. For the border, whatever the arrangement is, times 4 plus 4 will give you the total amount of tiles for the border, okay? Now, number 5 is really cool. Okay, let me explain it to you. So, for number 5, it says for using both 196 cubes for water and border. It's not just water, it's not just border, but the whole arrangement, how many tiles use 196 cubes, okay? Or tiles or whatever it is, okay? All I want to remind you, okay, all I want to remind you is right here. Remember those formulas for water and for the border, because you're going to have to use both of these to figure out which arrangement with these together uses 196, I guess this should say tiles. I don't really call these cubes, but tiles, okay? 196 tiles for both water and border. So these A's in here, when you figure out these together equal 196, this arrangement and this arrangement should be the same one, okay? And, okay, and then take a quick look at these. I know it looks like a lot, okay? It's actually a lot of pages. It's not a lot of work. So there's a lot of pages there, 5th grade, I know, but it's only Wednesday and you got till Sunday. It probably works out to about 45 minutes a day, maybe 40 minutes for you guys to do this. And that's just an average. Some of you will do it quicker than that. But I know I apologize, I know it's a lot of pages, but there's not a lot of problems per page. So it looks like a lot, but it's really not. Now the home connections, I think you can just go ahead and figure those out. I don't have time or the board space to go over home connections. Just do the best you can. And just keep thinking about what we talked about here. Look for patterns. If it's doing cube sequencing, look for patterns. Is there a formula that you could use to find out in the future, like arrangement 100, how many tiles would you use? Well, we could do that for the border and water, because we know if we stick in so many tiles, or arrangement 100, if we put in 100 for the arrangement, all we have to do is do the formula, okay? So do the best you can. I know it's a lot of work, but you'll end up going, oh man, I'm done sooner than I thought. So good luck, and from Studio B, this is Mr. Bauer signing off, and I'll see you Monday.